I'm Brian Waddell, and I'll be discussing sanitizers, disinfectants, and the process of disinfection. So to begin, there's 4 different levels of clean. The first being an environmental cleaning. That's just a standard general purpose cleaner to spray, wipe, and remove both solid and liquid soil from a surface. Now, when we just do standard cleaning in a normal lobby type setting or a community spot, the process of using a detergent, some sort of cloth, and manual agitation will remove a portion of any of the microbes on that surface. However, it won't control any specific type of microbe, and it won't guarantee that we're killing the stuff that's left over, the matter, the microbes that we aren't able to physically remove through that wiping process. So with environmental cleaning, we're going to leave behind some level of microbiology, virus, bacteria, etc. The opposite end of the spectrum, the 4th level, we're going to jump 1 to 4 and do opposite ends of the spectrum here, would be sterilization. Now, sterilization is not something that in the commercial cleaning industry we worry about or perform that action. That's typically done with extremely high heat or long-term exposure to the strongest chemicals. Almost exclusively reserved for healthcare and instruments in healthcare. The 2 that really apply to us in commercial cleaning. The first one is to sanitize. Now, sanitizing is a process, not a product, but a process that will remove the microbes, remove the population of microbes to a safe level. The most common place that we use sanitizers and actually sanitize surfaces is in food prep, cafeterias, food type areas. And the idea is to lower that microbe count on food utensils and food prep surfaces to a safe level that is okay for human contact. Now, sanitizers don't typically target any one specific microbe. Their goal, as I said, to remove it to a safe level, is to remove up to 99.999% of microbes on that surface. Again, nothing specific. It's not targeting cold virus, flu virus, E. coli, nothing specific. It's typically designed out. So we'll leave some behind. Far fewer. Disinfecting is similar to sanitizing, but at a higher level. Typically with stronger chemicals, maybe a longer dwell time. And the idea behind disinfecting is to remove, let's just get this, is to remove up to 100% of the microbes on that surface. The exception is that disinfectants will not kill or deactivate endospores or bacterial spores that are typically more to worry about in a healthcare setting. But if we perform the process correctly, we can remove up to 100% of microbes on that surface. Now, oftentimes sanitizers and disinfectants, there's kind of a gray area and they get referred to and confused, referred to each other and confused. But the easiest way to remember it is the application. Again, sanitizers typically food service, a few exceptions. And disinfectants are typically in patient rooms in healthcare, now in restrooms, some public areas that are high traffic. And now very commonly used in K-12 in schools to disinfect desktops, highly touched objects, some of those public areas, and even more so now that we've dealt with 2020 and the global pandemic. Now, how we accomplish this and where we get there is where there's some differences. So to cover some of the types of disinfectants, some of the chemicals that go into disinfectants and sanitizers in some instances, the active ingredient, if you will. So the first one to cover here is bleach. And we start with bleach because it's one of the most common, most widely used, and most everybody knows what it is, has heard of it, used it, been around it. That being said, it's one of the more harmful active ingredients and products that we can use for sanitizing and disinfecting. Bleach is a known skin and eye irritant, very easy to cause damage to a person using bleach on a regular basis. It's also extremely damaging to surfaces. We all know clothing, we get bleach or bleach water on our clothing. Unless it's white, it's going to take the color out of it and ruin it. Carpet, surfaces, etc. can all get bleached. Even surfaces that we don't see damage on from just spilling or one-time application, over time, that chlorine bleach will continue to degrade a surface, break it down, and cause permanent damage slowly over time. It can be very effective if it's mixed properly, typically 10 to 1, and dumped out and remixed very often. Some of the testing that we've done in the field and things have been corroborated by others and other facilities that I've worked with. If we mix bleach solution, chlorine bleach solution, in an ice cream bucket or another type of bucket or contraption here, when I mix that, I can use my chlorine test paper, test it, see that I'm at the correct part per million. But with it being open to air, I have about 25 minutes until that is deactivated to the point, or gassed off to the point that it's no longer above my part per million threshold to properly sanitize the surface. In order to get into disinfecting with bleach, sanitizing with bleach, much easier. We can use more of that household level or percentage of chlorine bleach, which is up to 5%. A different product, looks the same but slightly different, called disinfecting bleach or germicidal bleach, is 6% and up, typically 6 to 7%. That product gets mixed at the same type of mixture, but we get a much higher part per million. It will allow for a disinfection process rather than just sanitizing. Same issue though. Chlorine, when it's exposed to air, has a tendency to just gas off and weaken as it sits and waits. If we're mixing it in a sealed bottle, we might get a day or two out of it, but that's going to be about it. Beyond that, the other major issues, number one, bleach does not clean anything. There's no detergency in bleach. All we're doing with a bleach water solution is deactivating any microbes it can get to, assuming they're not in soil or buried and not accessible, and literally taking the color out of soil and surfaces and grime that we have on the surface. It does oxidize. It will break down to a point, soils, and allow us to remove them, but not near as effectively as a detergent would. Finally, the major thing with bleach that we always worry about is any type of mixing, or even inadvertent mixing. The common one that most people are aware of is that we cannot mix chlorine bleach and ammonia. We're going to create a chlorine gas that is dangerous and can be fatal. But less common that many don't know or aren't aware of is if we mix chlorine bleach with many bowl acids, again, even inadvertently, or other type of wet room acid cleaners, we'll get a very similar reaction that can gas off, be extremely harmful, and also fatal. So chlorine bleach, the first active ingredient, I guess base sanitizer disinfectant that many of us are familiar with. The next one that I'll just hit on briefly, not very common anymore, but it's still out there here and there, are phenols or phenolics. So phenolics were very common a couple decades ago. Many of them that I still see out there, because again, they're still around, are an aerosol type, almost a walk away and let that chemical work, possibly go back and wipe up, but more of a Lysol type spray. The problem with phenolics is that they do not clean either. Like chlorine bleach, it doesn't have, most of them do not have a detergency mixed in or married with them that allows us to use a one-step clean and disinfect process that most of us are familiar with at this point. Again, they're around, not very common, but to be aware that is another type of disinfectant is good. The most common sanitizer and disinfectant that we see now are quat-based. Quat, short for quaternary ammonium compound. So over the last couple of decades, quats have become one of the most prevalent, one of the most commonly used sanitizers or disinfectants, again, depending on the application and the product. But quats are number one, far less harmful to the person, to the cleaning worker, to the building occupants, than phenolics and chlorine bleach is. But they're also much less expensive than many alternatives to use. The big sell, the big improvement of using quats over some of the others is that in the manufacturing process, they can be married or mixed with detergents, which is what gives us many of the one-step disinfectant detergent, disinfectant cleaners that we see now. Oftentimes, disinfectant detergent or neutral disinfectant cleaner, 9 times out of 10, those are quat-based disinfectants. Again, safer, relatively inexpensive, and can be married into a one-step cleaner disinfectant. The downside of quats, those are the upsides. The downside of quats is typically the dwell time. Many of the more common quat-based disinfectants have a dwell time, meaning it has to stay wet on a surface for the recommended, or the required, I should say, the required dwell time. Oftentimes, or most commonly, you'll see quats with a 10-minute dwell time, meaning I have to take my product, spray it or apply it to my surface that I want to disinfect, and allow it to remain wet for 10 minutes before I can come back and wipe that up. Now, if I'm cleaning 25 desks in a classroom and I've got 12 classrooms to clean tonight, or I've got 8 public restrooms, whatever it may be, most of us don't just have 1 or 2 desks and tables that we're cleaning per day. Most of us and most of you have many hours of work and many rooms to clean and disinfect the surfaces. And in most instances is not feasible or realistic. Now, that being said, over the last several years, we've seen a number of more concentrated quat-based disinfectants that are now only a 3 to 5 minute dwell time, which does help. It helps that process and allows for a much shorter dwell time. But in order to get that shorter dwell time, we're increasing the part per million, or the strength, if you will, of that quat-based disinfectant. So we're just using more chemical. And anytime we just add more chemical, that's more chemical that you as a cleaning worker are exposed to, especially if we're spraying it and aerosolizing it, and more chemical that we're putting into the air in the buildings that we're in, and more chemical that we're we're possibly leaving as residue on the surfaces that we're cleaning and attempting to disinfect. So good side, bad side. The last one of the most common is hydrogen peroxide. So hydrogen peroxide is not a new chemical, but it is a little bit newer to commercial cleaning in the sanitizing and disinfecting realm. Probably over the last 15 years, there have been a few innovations in hydrogen peroxide and in accelerated hydrogen peroxide that give it many of the same qualities that we have out of chlorine bleach and many of the same qualities we have out of quats. Similar process to breaking down microbes as chlorine bleach has, but we're able to take that hydrogen peroxide in many cases and when it's being manufactured, allowing for a one-step cleaner disinfectant. Safer product and typically a shorter dwell time. The next generation disinfectants that are utilizing hydrogen peroxide, many of them only have a 1-minute dwell time up to 5-minute dwell time, but typically shorter than we see out of quats. Now, the idea of how we're disinfecting, how we're accomplishing the task of disinfection using the disinfectants that we just discussed. The most common way, the most common tools or application method that I still see out in the field and around is spray bottle and cloth. It's effective and it's simple. However, there are a few issues with it if we're cleaning large areas or a number of different rooms or area types. Just to quickly hit on a couple. If I have a 1-minute dwell time or 10-minute dwell time, that'll kind of play into this process. So if I'm using this, and the idea is that I have to spray a surface until it's saturated. On most of these, if we read the label, it'll say totally wet the surface. Okay? If I have to totally wet the surface, I've just taken multiple sprays with my hand. That's on one table. You know, maybe that was a desk or two if I'm cleaning classrooms. That's a lot of this action throughout an entire evening, which can lead to repetitive motion issues and can be just downright annoying. But if I use the spray method and I spray all over this tabletop, a couple things beyond just spraying. Number one, now I'm waiting, and I would watch the clock and give myself, in this instance, 5 minutes of dwell time. So I've got to let this sit wet for 5 minutes. It's a long time in the cleaning world. 5 minutes is a lot of time that I can get done a lot of other things. Beyond the time, beyond the spraying action, if I'm spraying and we see every time we spray this plume of chemical and solution that goes up, it's what we call aerosolization. So as I aerosolize that product, I'm now breathing it in, I'm putting it up into the air, and I'm giving myself unnecessary exposure, frankly. I'm also spraying, and maybe the wall behind me, the chair at the table, the floor underneath it are all inadvertently getting sprayed with my disinfectant. So now I've put chemical with detergent in it. The detergent's very sticky and will leave residue behind. I'm spraying it off onto surfaces that I'm not intending to apply it to, because there's no other good way to get all the edges and surfaces on this tabletop without some sort of overspray. So I try to contain my spray. I try not to breathe in any of the aerosolized chemical, a chemical that's designed to kill microbes, very harsh, that I'm now breathing in and exposing my skin to. And I cover it with the table here with it, and I wait for my 5 minutes, and then I come back and wipe it up. So multiple steps in that process. There's better ways. There's better ways of doing it than doing a spray and wipe, wait and go. First thing that we need to remember, a saying that we have at BRUCO that we use quite frequently is you can clean without disinfecting, but you cannot disinfect without cleaning. Ultimately, here's the deal. If I read any of my sanitizers and disinfectants, I read the label and the directions. In order to complete the process and actually fulfill all the requirements to disinfect a surface, I have to clean it first. I have to remove all gross soil before application of that product in order to satisfy the requirements. That would mean that I have to go through and first clean everything, all those tabletops and doorknobs and touch points, and then come back in and reapply it, let it sit, get my dwell time, and come back and wipe it all up again. It's not realistic. And honestly, in most instances, surfaces don't get truly disinfected because we're not doing a two-step process. It's just too much time. Most places, most professional cleaning workers that I'm around and speak to do just the one step. We spray it, we wipe it, and we keep it moving. We've begun recommending a pre-treated method. We pre-treat our microfiber cloths to allow for a more streamlined operation, allow ourselves, without taking multiple steps, to satisfy all the requirements on those labels, and really to make it easier on ourselves and quicker, frankly, more efficient. So I pre-treated just a couple so that we can discuss the process here. The idea is very simple. We have microfiber in a bucket on a cart, a type of system. We color code it so that we know red cloths, red means dead, and green cloths, green means clean, for just standard cleaning, dusting, etc. But we use a red cloth for our disinfection. And rather than coming in and spraying and getting that overspray and aerosolizing it and breathing it in, now all we're doing is walking into a room up to a surface. And if I've got a flat surface, again, these are saturated. These are soaked. They've got plenty of disinfectant solution on them. Not so much they're dripping. We don't want dripping off of the cloths. They're similar to a bucket of Clorox wipes. We pick one up out of our bucket and we begin operating and using it. Again, we're not dripping. We're not having to wring out. We're just grabbing and cleaning. Now with this method, I don't have to spray. I don't have to aerosolize the chemical or the chemical we're using. I don't have to worry about overspray. And I eliminate a number of steps. So if I've pre-treated my cloths, my microfiber, I can just grab it, wipe any of my flat surfaces, or grab this, and whether it's a doorknob or the side of a table or any of those odd surfaces, I can use a cloth to wipe those surfaces and get them saturated. And then I walk away and allow it to air dry. So my pre-cleaning is actually, my removing the gross soil, my pre-cleaning gets accomplished while I wipe and wash or clean that surface. I remove all the gross soil, and the disinfectant is left behind to work and do its job, accomplish its required dwell time, and it will just air dry on the surface, and we move on and keep about it. Much simpler, much easier, much less strain on our hands, and fewer steps. Just frankly faster and easier, and a little more healthy for the cleaning worker, for you. Thank you.